The examples in this video are designed to have a more practical understanding of the PV diagram and the quality in particular. The video starts with a short overview on the PV diagram to visualize the fluid aspect in specific zones of the PV diagram. Then the video moves the focus on the two-phase zone, where through the quality we can identify the proportions between liquid and vapor. We are given a cubic vessel of 1 square meter containing water. By reading from a pressure gauge and a thermometer, we know that water is at 80 bar and 390 degrees Celsius. Having the PV diagram of water at hand, we enter the two values and discover water is in the superheated vapor state, so the vessel contains all vapor. The same vessel is now at 60 bar and 30 degrees Celsius. From the PV diagram, we cross the isotherm at 30 degrees Celsius and the isobar at 60 bar and discover water is in this case all liquid. We are now given a vessel in which water is present in two coexisting phases, liquid and vapor. The vessel is transparent and we can see that the liquid occupies 1/5 of the whole volume, the rest being water vapor. The vessel has only a thermometer now, and we read the temperature of 270 degrees Celsius. We would like to know the quality of the water inside. There is no need for the pressure here, since the vessel is transparent, and from visual inspection we know there are a liquid and vapor fraction, so water is at saturation. Under the vapour-liquid dome, isobars and isotherms are both flat. From the PV diagram, when water is at saturation and at 270 degrees Celsius, then water has a pressure of 55 bar. The liquid volume in the vessel is 1/5 of the total, 0.2 cubic meter. The vapor takes instead 0.8 cubic meters. Being at saturation, the specific volume of the liquid fraction in the vessel is the saturated liquid specific volume, which is approximately, from the horizontal axis, 0.001 cubic meter per kilogram. This gives 0.2 cubic meters over 0.001 cubic meter per kilogram, 200 kilogram of saturated liquid water. Similarly, for the specific volume of the vapor fraction, it is the specific volume of the saturated vapor, which is from the graph 0.035 cubic meter per kilogram. This gives 0.8 cubic meter over 0.035 cubic meter per kilogram, 23 kilograms of saturated water vapor. The quantity of water in the vessel is therefore 223 kilograms. Being the total volume of the vessel 1 cubic meter, the specific volume of the overall two-phase fluid is 1 cubic meter over 223 kilograms, 0.0045 cubic meter per kilogram. The quality is the ratio between the mass of saturated vapor over the total mass of the water in the vessel, that is 23 kilograms over 223 kilograms, 0.1. Therefore, by dividing the tie line in 10 equal parts, the state of this system is located close to the beginning of the tie line, towards the saturated liquid branch of the vapour-liquid dome,